Welcome to the great live electrical engineering. How and why 100 years of wisdom is being ignored. By me, Malcolm Davidson, the author of this document. I sometimes think that we are successful in spite of, not because of our basic theories. And what I've noticed in the last many years is that there is a true cognitive dissonance in science. And this scientific problem is really a challenge of human psychology because they have a fear of rejection. They have a need to be accepted, a need to be validated. Academics have to justify what they teach. But when you really look at it in detail, it does not stand up to scrutiny. And the problem is all about cause and effect. Do we care about the truth? Do we really care about the truth, or do we just talk about caring? Do professors and teachers, do they have the courage to change? Because the problems that we've observed over the years in the electronics industry, covering the airlines, the military, and so forth, the cost runs into many, many millions of dollars with lost development time, redesign efforts, crosstalk problems, and so forth. One thing we know is that one of the reasons why people are afraid to change, that the gravitational pull of conventional wisdom is strong. People want to belong. Anyway, I want you to follow along to see the lie exposed. What all engineers and students of physics and electronics learned, and they learned today, as I learned back in the late 60s and early 70s, that when an electric current flows in a wire, it creates a magnetic field around the wire. An electric current is a flow of electrons in a wire. And conventional current plus I is defined as flowing in the opposite direction to the flow of electrons. Electrons are part of the atomic structure of elements. What we know today in the computer world and the IT world is that the ubiquitous USB standard is now all over technology. USB 1 came about in the late 90s and had a transfer rate of approximately 12 megabits per second, and now through 2, 3, and now into USB 4, we've got a maximum transfer rate of 20 gigabits per second and even faster. So understanding the way digital signals, binary data, propagates in cables and across circuit boards and across chips is vital that we know and understand the basic theories, the correct theories. Here we have a digital step traveling along a transmission line, and a transmission line is the elemental connection between points A and B. And on the left you can see a typical USB serial cable. What is electric current in a USB cable? If you look on the left, we can see that we have a typical sketch that has been shown to students across the world for millennia. We have a battery with a closed circuit lighting a lamp. And we have conventional current flow from the plus going through the light and back to the battery. Electron flow is in the opposite direction. And there it is sketched out on the right. The conventional model of electric current, as we know, shows the digital signal propagating down the transmission line, down the cable, from the source of the pulse. We have plus I in the top wire, we have minus I in the bottom wire, and we can see that we have electrons supposedly flowing from right to left in the top wire and left to right in the bottom wire. Now, of course, remember that signal is traveling propagating down the line at the speed of light for the signal. Here we see a sketch of some copper atoms. Copper has a atomic number of 29 with one electron orbiting the valence or outer orbit. In the top wire, we have electrons moving from right to left, as we see on the right-hand side, and in the bottom wire, we have electrons moving from left to right. Here we see the leading edge of a US binary signal, plus I and minus I, and then we can see the loop that I sketched in red showing the current. Now remember, that signal travels down, propagating down that transmission line, that twisted pair, that USB cable, that coaxial cable, at the speed of light for the medium. And the medium, the transmission line, has a characteristic impedance Z0, and it has a speed c, and they are both defined by mu and epsilon as primitive elemental values. Mu is the permeability and epsilon is the permittivity of the medium. And just for people as a reference, the characteristic impedance of free space is 377 ohms or 120 pi, and the speed of a TEM wave or a light wave in space is 3 times 10 to the 8 meters per second. Now, part of the challenge is a cause and effect problem. The signal travels at the speed of light for the medium. However, electrons have mass and cannot travel at that speed. Yet, we are taught that electrons are like billiard balls pushing each other along inside the wire to create a magnetic field H, which travels in phase with the signal, with that pulse. And the question arises, how can something traveling slower cause an effect which is faster? Here we have an example from YouTube by Jan Visual Physics of conventional current flow. There we see the battery with electrons coming out of the negative terminal, looping round through the lamp and coming back through the positive. That is what is taught. And by the way, I equals Q over T, which is the charge per unit time through a cross-sectional area of wire. That is what is taught to every student across the world. Here we have another model, another simulation by Power Bytes, same thing. Here we see electrons coming out of here, round through the light, back up and returning into the battery. This is how it is taught across the world in 2021. And yet we know that that digital signal you see here is traveling at the speed of light for the medium. As we saw before, the current loop is shown in red. And the question is, if this conventional theory is correct, in the top wire we have electrons, according to conventional theory, pushing back, moving back, propagating back towards the source. And the question is, what is the force pushing those electrons back towards the source of where that pulse came from, knowing that that pulse is traveling at the speed of light for the medium? Here we have the definition of current. An electric current is a flow of electrical charge in a circuit. The electric current is the rate of charge flowing past a given point in an electrical circuit. The charge can be negatively charged electrons or positively charged carriers. However, there is an alternative view, and here is a sketch. If we imagine all of the energy which we can call electrical energy current, flowing in the space between the wires. This signal, this binary signal, this digital pulse, is called the Poynting vector, E cross H. It is an acceptable idea that was promulgated by Poynting and Oliver Heaviside over 100 years ago. And that step is a TEM step, a transverse electromagnetic signal. In the same way that when cars travel down a highway, as you see here, the trees and the leaves waft in the breeze. The trees moving and the leaves wafting around does not push the cars along. It is the same with electrons in the TEM pulse. The TEM pulse, traveling between the wires, enters the wire because it is not a perfect guide and imparts energy to the electrons, causing them to move. Here is a USB 4 signal. The rise and fall times are approximately 5 to 15 picoseconds. What is going on at the leading edge of the binary signal? Does conventional theory stand up to scrutiny? All USB twisted pairs, coaxial cables, circuit board traces, as I mentioned before, they can all be seen as transmission lines that have two parameters, the characteristic impedance and a speed of propagation v. Of course, in free space, it is the speed c, same as light. When the switches close, S1, the step immediately begins to propagate down this transmission line towards the load or destination. There would be an applied voltage V across the conductors, and it's there because of that TEM signal. And there will be a current flowing that we can measure because of the TEM signal. And we mentioned before that current is defined as a flow of electrons. But we actually realize that that is an effect and not a cause. And here we see again that very familiar sketch of electrons flowing from in the bottom conductor towards the load and away from the load back towards the source in the top conductor. With the conventional perspective, if these electrons that we see below are causing the magnetic field H, does that mean something is flowing across the front edge of the binary signal, which again is traveling at the speed of light for the medium? We know electrons have mass and cannot move instantaneously. If they have mass, they also have inertia, and it has been proven that they have inertia. How can electrons travel back towards the source of the signal? If the signal travels at the speed of light from left to right, that signal front only knows where it is in the moment. It knows nothing else about what's going on in space, anywhere else in the universe, only itself. How can the electrons travel back? What is the force pushing them back? Here is a simulation that I created of the conventional perspective. Here we see electrons flowing up, across, and back and round. This is what we are taught, opposite direction to the flow of current, which is plus I and minus I. Some basics. Space has the ability to accommodate energy. All electrical energy travels at the speed of light for the medium, and all mediums possess two basic quantities, Z0 and time delay. And as I mentioned before, Z0 and time delay are defined by permeability mu and permittivity epsilon. Any period of space, any region of space separated by 2 points can be modeled as a transmission line. An electron has mass. It's albeit very small, but it has a mass. And nothing can travel at the speed of light if it has mass. As I mentioned before, electrons have inertia, and electrons are over 1,000 times smaller than the proton. There is no such thing as a stationary electric field. There is no region of space where c or v, the velocity, is zero. That is, unless you are inside a superconductor, and a superconductor is a perfect obstructor for electromagnetic signals. And whenever the boundary conditions of a transmission line change and a signal is propagating, a perturbation occurs. Some more basics. A digital step is a TEM signal or pointing vector, otherwise we know it as E cross H. It has a magnetic field H and an electric field E, and they are right angles to each other and to the direction of motion. A capacitor is a transmission line. Also, an inductor is a transmission line, and a resistor is a transmission line. And a capacitor as a transmission line, when there is an applied voltage to the two plates, it causes the signal going from left to right to be different from that going right to left. Hence, we can measure an H and we perceive that as so-called current flow. There is no magic in it. So the idea of a displacement current inside of the capacitor is erroneous. It is not necessary. We talked before about cause and effect. Electrons flowing in a copper wire do not cause a magnetic field around the wire. So-called electron flow is caused by the TEM signal outside the wire. As I mentioned before, the TEM signal, guided by the wire, enters the conductor and imparts energy to those free, the valence band electrons, causing them to move. Copper has an atomic number of 29 and one electron in its outer or valence band orbit. Any movement of those free electrons is an effect of the signal outside of the cable and not a cause of the signal outside. TEM energy moves at the speed of light because that is what TEM waves do. The pulse is just a block of TEM energy, the pointing vector E cross H. And as that signal propagates down the transmission line, as I mentioned before, E and H are in phase with each other. They do not know of anything except where they are in a moment. A perfect conductor, where nothing enters the wire, is what we can call a perfect obstructor. There is zero penetration into the wire or the guiding medium. Another term for a perfect obstructor is a superconductor. A TEM wave is a fundamental wave of nature, and other waves are a combination of this primary energy form, E cross H. There's TE waves and TM waves. The step or shock wave leaves the source and travels between the wires. However, in a typical copper wire, some of that energy penetrates the wire, causing the electrons to move. In the upper conductor, the energy vector pushes them backwards. And remember that energy vector of the H field, which is around the wire, and the energy vector of the E field is between the wires. In the top wire, they tend to push those electrons back where they came from. And in the bottom conductor, these combined vectors push the electrons towards in the same direction as the direction of propagation of the signal. Here we see a step, a series of pulses. Here we could have 1, 1, 0, 0, 1, 0, 0, etc. And when there is a 1 on the transmission line, some of the energy current, the E cross H signal penetrates the wire, and then when there is a zero, that energy depletes and disappears. So we have the signal doesn't go far in, and the higher you go, the less it goes in, and that is what we might call the skin effect. In the first picosecond after a switch is closed, according to conventional theory, somehow there are electrons already moving back towards the source. Because we know the 1 picosecond after we close the switch and the signal propagates, we will measure a binary step on that top wire, a voltage V, whether it's 1 volt, 2 volts, 5 volts. That is accepted by all engineers across the world. My question is, if the conventional theory were correct, then in that first picosecond, the signal in the top, somehow the electrons have to come out of the bottom, run around the front edge of the signal, and then back towards the source. So the electrons would be traveling twice the speed of the signal to get back to the beginning. Obviously, this is not possible. And here we have that model that we talked about, we showed before. There's the electrons going at twice around. That is not possible. Oliver Heaviside introduced the idea of a binary step as what he called energy current back in the 1870s. He deduced that it was the vector product of an electric and magnetic field, E cross H. And he extended this by treating the transfer of energy due to the electric current in a conductor in a similar manner. In doing so, he reversed the contemporary view of current, so that the electric and magnetic fields due to the supposed current are the prime movers, rather than being a result of the motion of charge in the conductor. We reversed this. Heaviside stated, now in Maxwell's theory there is the potential energy of the displacement produced in the dielectric parts by the electric force, and there is a kinetic or magnetic energy of the magnetic induction due to the magnetic force in all parts of the field, including the conducting parts. They are supposed to be set up by the current in the wire. We reverse this. We reverse this. The current in the wire is set up by the energy transmitted through the medium around it. This was stated by Oliver Heaviside 150 years ago. Not yesterday, 150 years ago. And yet, the electronics industry has been teaching the opposite of this for all these years. We will repeat. Oliver Heaviside, he stated, in our language, the current in the wire is caused by the more primary flow of energy current in the space between the wires. The current is a secondary effect and not the primary causes of the E cross H signal propagation. As Heaviside saw it, telegraphy was ultimately about sending energy cleanly without a distortion along a wire. In the same way, telegraphy 150 years ago is the same as digital electronics in 2021. And we want to send energy cleanly without distortion along circuit boards, inside integrated circuits, in automobiles, in cables, in aeroplanes, in automated factories, and so forth. So we need to have a solid theoretical underpinning to make this happen so that we do not have problems. Heaviside deduced that S, the power flow of energy at a point in space, is merely the product of E cross H, a very simple equation. We know that as the Poynting vector. And the energy of an electric current does not flow within the wire like water in a pipe, but instead it passes through the surrounding field and enters the wire through its sides. And this is important. J. A. Fleming, in about 1910, he also observed, "It is important that the student should bear in mind that although we are accustomed to speak of the current as flowing in the wire, in one direction or the other, this is a mere form of words. What we call the current in the wire is, to a very large extent, a process going on in the space or material outside the wire. Just as we familiarly speak of the sun as rising and setting when the effect is really due to the rotation of the earth, so the ordinary language we use in speaking about electric currents flowing in conductors retains the form impressed upon it by older and erroneous assumptions as to their nature." And Dr. E. A. Guillemin, in the Standard Handbook for Electrical Engineers, Fink and Carroll, 10th edition in the 1950s, the electromagnetic field surrounding the conductor produces, through a small drain on its energy supply, the current in the conductor. And I quote, "The usually accepted view that the conductor current produces the magnetic field surrounding it must be displaced by the more appropriate one, that the electromagnetic field surrounding the conductor produces, through a small drain on its energy supply, the current in the conductor. Although the value of the latter may be used in computing the transmitted energy, one should clearly recognize that physically this current produces only a loss, and in no way has a direct part in the phenomenon of power transmission." And in our world as electronic engineers and digital designers, we can talk about I squared R losses in a length of copper wire. Some final thoughts on the TEM wave propagation. Energy current, or the Heaviside signal, travels at the speed of light always. Light waves from the sun and elsewhere in space are TEM waves. Energy current is the cause of heat in a conducting wire, as it has given up energy to the molecules. Anything perceived moving in a wire is an effect of the more basic energy traveling in the space between the wire. And we have been teaching incorrect ideas for over 100 years. And indeed, since the mid-1970s, the electronics industry and academia has not been receptive to many articles and papers that have been written promulgating Oliver Heaviside's ideas of energy current. Now is the time to place the electronics industry on a more secure, theoretically sound footing. We seek truth elsewhere, why not here? What are some of the benefits of correct theory regarding TEM wave propagation? Circuit board designs can be performed in less time. As integrated circuits and board designs continue to get smaller, it is a mandate that we should have a solid theoretical footing to be able to lay them out correctly and properly. Interfaces between systems are becoming ubiquitous, whether it's cars, buildings, etc. And we need to be able to transmit our digital signals without loss, without distortion, at higher and higher speeds. So we need to have a proper theory for this. Correct theories provide tools for correct and minimal design criteria. Correct theories provide opportunities for elegant designs of systems. And a result of using correct theories is that complex designs such as planes, ships, etc., can be more reliable, and costs can be reduced at all levels of a product life cycle. Noise reduction and mitigation can be achieved in high power systems. Think about desktops, laptops, iPads, cell phones, and so forth. All the components that are used for noise mitigation, for ripple minimization on the DC supply, where tiny capacitors are used, which with a proper understanding may not be required. That mapped out across the world could save many millions of dollars. Now, of course, here we have some comments about the search of truth, which for me, as I said before, the most challenging problem here isn't technical but psychological. And feel free to contact me if you have any comments. I welcome all feedback. Truth is part of our ability to have coherent thinking. Coherent thinking is another way of saying it's joined up thinking, joining up the dots of disparate views so we can have a coherent and holistic theory mapping into correct designs. Cognitive dissonance is stressful and can cause ill health. When we are in right relationship with nature, it can be blissful. And maths is not reality. Nature is reality, and just because a series of equations are consistent does not mean that they are correct. So finally, the great lie of electrical engineering, the problem is not that there are no correct theories, because the proper and accurate models have existed for over 100 years. The problem is human psychology and the phenomenon of fear. And rare are the individuals who break ranks and step into truth and away from falsehoods and improper theories. Everything must stand up to key technical scrutiny, and the idea that electron flow causes a TEM signal does not stand up to key technical scrutiny. Are we going to continue to be ego-led or truth-driven? The choice is yours. Thank you very much.